Imagine driving an electric car that doesn't rely on a giant battery pack mounted underneath it. Instead, the battery is built right into the vehicle's structure. The floor, the frame, and the body all work together as part of one integrated system. Even more impressive is how incredibly fast it charges. You simply pull up to a charger, plug it in, and by the time you've checked a few messages on your phone, the car is already ready to get back on the road. And it's not just partially charged, it has enough power to travel more than 600 miles. This isn't a futuristic concept being displayed at a technology exhibition. It's a real production vehicle that's available today. What's even more surprising is the company behind it. They didn't begin as an automobile manufacturer. Their journey started in a small rented room where they built rechargeable batteries for mobile phones. That humble beginning is the very reason they achieved something that many experts believed was impossible. If you've ever been annoyed by long charging times, worried about running out of battery during a trip, or questioned whether electric vehicles are truly practical for everyday life, this story is about to change your perspective. In this video, we'll explore how BYD made this breakthrough, why the announcement they made in early 2025 stunned the entire automotive industry, and what it could mean for the next generation of electric cars. If you're enjoying videos like this, make sure to hit the like button. It only takes a second, but it really helps the channel grow more than most people realize. And don't forget to subscribe so you never miss what's coming next, because this is only the beginning of an incredible story. Now let's go back to where it all started. To understand why this innovation is so important, you first need to understand the company behind it. BYD's story didn't begin in Silicon Valley or inside a famous European engineering center. It began in 1995 in a small rented room in Shenzhen, where a man named Wang Chuanfu set out with a simple goal: to manufacture rechargeable batteries for mobile phones. At that time, mobile phones were becoming more popular every day, creating enormous demand for reliable batteries. Wang recognized this opportunity early and decided to focus on producing high-quality batteries at prices that competitors couldn't match. As the company grew, BYD developed an extraordinary understanding of battery technology. They didn't just manufacture batteries, they learned every detail about how they worked, what made them efficient, and what caused them to fail. Their engineers studied every material, every chemical reaction, and every possible weakness. When BYD entered the automotive industry in the early 2000s, that knowledge gave them a completely different way of thinking. While traditional car companies designed vehicles first and then selected a battery to fit inside, BYD approached the challenge from the opposite direction. They designed the battery first and built the entire vehicle around it. That difference may sound small, but it completely changed their strategy. Most automakers viewed the battery as just another component supplied by someone else. BYD viewed it as the most important part of the vehicle because it was the technology they understood better than anyone else. By 2020, this unique mindset encouraged them to take a bold risk that many people in the industry believed would never succeed. Instead of following the latest battery trends, BYD focused on lithium iron phosphate, commonly known as LFP, battery chemistry. Many competitors had already moved away from it because it stored less energy than newer battery technologies. It had earned a reputation for being the cheaper and less capable option. However, BYD saw strengths that others ignored. They recognized that LFP batteries were naturally safer, lasted much longer, and could be produced at a lower cost. Rather than accepting their limitations, BYD completely redesigned the battery cells. They created long, thin cells shaped like blades and arranged them tightly together with almost no wasted space. By removing bulky battery modules and unnecessary protective casings, they packed far more usable energy into the same space while keeping the structure simple and efficient. To prove just how safe their new blade battery really was, BYD performed an unforgettable demonstration. They drove a fully loaded 46-ton truck directly over the battery pack. Despite the enormous weight, the battery didn't catch fire, didn't leak, and showed almost no significant damage. Wang Chuanfu even said that his goal was to remove the phrase spontaneous combustion from discussions about electric vehicles altogether. That level of confidence only comes when you design, build, and understand every single part of the technology yourself. The Blade battery was a major breakthrough, but it was still a separate battery pack that had to be installed inside the vehicle. The next innovation would take things much further by changing the way electric cars were designed from the ground up. Before we get to that breakthrough, it's important to understand the biggest problems facing today's electric vehicles. Modern EVs have made incredible progress and offer many advantages, but they also come with several frustrations that advertisements often avoid mentioning. Long charging times, range anxiety, and other practical limitations continue to affect the experience for many drivers, and solving those issues became the next major challenge for BYD. These everyday frustrations are exactly what BYD set out to eliminate. Let's begin with charging time. Electric vehicle advertisements often highlight fast charging, but the real-world experience can be very different. At most public charging stations, it still takes around 30 to 40 minutes to add a useful amount of charge. That's not a quick stop. It's enough time to finish a meal, have a long conversation, or read an entire chapter of a book. For people who are used to spending just 5 minutes filling up a gas tank before getting back on the road, this feels like a major inconvenience. It changes how you plan road trips and adds another layer of thinking that drivers of gasoline cars simply don't have to deal with. Then, there's the issue of driving range. Most reasonably priced electric vehicles today can travel between 250 and 300 miles on a full charge. While those numbers sound impressive, they're achieved under nearly perfect conditions. That means comfortable weather, steady driving speeds, and minimal use of heating or air conditioning. Real life is rarely that ideal. During winter, battery performance can drop significantly. In extremely cold temperatures, driving range can decrease by 30% or even more. That's because the chemical reactions inside the battery slow down when it's cold, and the vehicle must use some of its stored energy simply to keep the battery warm enough to operate efficiently. Cold weather also affects charging speed. A charger that works incredibly fast during the summer may deliver power much more slowly in the middle of winter. Many EV owners have experienced waiting far longer than expected while watching the battery percentage increase little by little as freezing temperatures make charging less efficient. There's another issue that most advertisements rarely mention. Nearly every electric vehicle currently on the market is built around a large battery pack installed underneath the floor. That battery pack has only one purpose: to store electricity. It doesn't contribute to the strength of the vehicle's structure. Because of this, engineers have to design the entire car around a massive, immovable battery box. It's similar to building an entire house around a giant piece of furniture that can never be relocated. The battery is installed first, and every other component has to fit around it. This design creates several engineering challenges. The battery pack adds a tremendous amount of weight, yet that weight does very little to strengthen the vehicle itself. A heavier car requires more energy to move, which means manufacturers often need an even larger battery to achieve the same driving range. But adding a larger battery increases the weight even further. It's a cycle that constantly works against efficiency. Concentrating all that weight into one large block beneath the floor also creates additional design challenges that every electric vehicle manufacturer is trying to solve today. BYD looked at all of these problems and reached an important conclusion. Simply making small improvements to existing designs wouldn't be enough. The entire concept needed to be reimagined. Instead of fixing one problem at a time, They wanted a solution that addressed all of them together. That led them to ask a question that almost no one else in the industry had seriously considered. What if the battery didn't just power the car? What if the battery actually became part of the car itself? At first, the idea sounds almost impossible, but once you understand the engineering behind it, it begins to make perfect sense. Rather than building a separate battery pack and installing it underneath the vehicle, what if the battery cells themselves became part of the car's structural framework? Instead of serving only one purpose, storing energy, they could also strengthen the vehicle at the same time. This is exactly what BYD achieved with its cell-to-body technology. Instead of placing a large battery box beneath the passenger cabin, the top surface of the blade battery becomes the actual floor of the vehicle. In other words, passengers aren't simply sitting above the battery, they're sitting directly on a structural part of it. The battery cells are integrated into the vehicle's skeleton, helping distribute impact forces throughout the frame in much the same way steel beams support a building. Think of the difference like this. The traditional approach is similar to attaching a heavy backpack underneath a car. It adds weight, but the vehicle has to carry it without receiving any structural benefit. BYD's approach is more like the human skeleton. Your bones don't simply exist inside your body, they support your weight, absorb impacts, and make every movement possible. BYD designed its battery to perform the same role. This new architecture delivers benefits across almost every aspect of the vehicle. According to BYD's engineering tests, the new design improves the car's structural rigidity by roughly 70% compared to its previous generation. That level of stiffness is usually found in premium luxury vehicles that rely on expensive materials and advanced engineering techniques. What's remarkable is that BYD achieved similar results not by adding more costly materials, but by completely rethinking how the battery fits into the vehicle. The improvements don't stop there. Because the separate battery enclosure has been eliminated, far more of the available space can now be used for actual battery cells. Around 76% of the total battery system is now dedicated to storing energy. In older battery designs, a significant amount of space was occupied by protective casings, support structures, wiring, cooling channels, and other packaging components surrounding the battery pack. Removing those unnecessary layers allows the same physical space to hold much more usable energy. That's one of the biggest reasons BYD's newest electric vehicles are capable of traveling more than 600 miles on a single charge. They didn't simply install a much larger battery. Instead, they redesigned the system so that nearly every inch of available space contributes directly to storing energy. An added benefit is lower weight. Since the bulky outer casing and extra structural components are no longer needed, the vehicle carries less unnecessary mass while storing the same amount or even more energy, improving both efficiency and overall performance. Reducing weight brings several advantages. A lighter vehicle consumes less energy, which naturally increases driving range. But the benefits don't stop there. Since the battery is now a structural part of the vehicle, the entire car becomes stronger and more rigid. That extra stiffness improves handling around corners, reduces vibrations, and gives the car a more stable, premium feel at high speeds. As impressive as all of these improvements are, they weren't the announcement that stunned the automotive world in early 2025. That moment came when BYD revealed one astonishing number. During its launch event in March 2025, BYD explained the engineering behind its latest electric vehicle platform. At first, the audience listened with curiosity, appreciating the technical details. Then the company displayed a single charging statistic on the screen that immediately changed the atmosphere in the room. The new system could charge from 10% to 70% in just 5 minutes. 5 minutes. To achieve this, BYD developed an ultra-fast charging system capable of delivering an incredible 1,500 kilowatts of power, roughly 40 times the output of a typical home charger. According to the company, drivers can go from almost empty to well over two-thirds charged in about the same amount of time it takes to use the restroom and grab a quick snack. One of the best examples is the BYD Seal 08, where a 5-minute charging session is claimed to add approximately 400 kilometers, or about 250 miles, of driving range. Think about that for a moment. 250 miles added in only 5 minutes. This isn't just a small top-up to help you reach the next charging station. It's enough energy to continue an entire road trip without worrying about the battery. For people who regularly travel long distances, this kind of charging speed has the potential to eliminate one of the biggest concerns surrounding electric vehicles. But charging speed isn't the only challenge BYD wanted to solve. Cold weather has always been one of the biggest obstacles for EV owners. Freezing temperatures reduce battery performance, increase charging times, and make long-distance travel more difficult. BYD claims its latest technology performs very differently. Even at temperatures as low as -30 degrees Celsius, the kind of extreme cold where car door handles can become brittle enough to break, they say charging from 20% to 97% takes only about 3 minutes longer than it would under normal conditions. Just 3 extra minutes. Not 30, not 50. Only 3. If these results hold up in everyday use, it would represent a dramatic improvement over what most electric vehicle owners currently experience during winter. Today, many EV drivers spend a significant amount of time waiting while their vehicles slowly warm the battery before it can accept a fast charge. As a result, charging speeds often drop dramatically whenever temperatures fall. BYD approached this problem by designing advanced thermal management directly into its cell-to-body battery architecture. Instead of allowing the battery to become too cold, the system actively keeps the cells within their ideal operating temperature, helping maintain fast charging performance even in extremely harsh climates. The flagship vehicle showcasing this technology is the Yangwang U7, BYD's premium full-size luxury sedan. Under China's official testing standards, the company claims it can travel more than 1,000 kilometers on a single charge. Real-world driving conditions will naturally produce lower numbers depending on weather, driving habits, and road conditions. Even so, the expected range remains outstanding by today's industry standards. Of course, having an incredibly fast-charging car only matters if drivers actually have access to chargers capable of delivering that speed. Fortunately, BYD had already been planning for that challenge long before launching the vehicle. A charger capable of delivering 1,500 kilowatts isn't something that can simply be connected to an ordinary electrical supply. Providing that much power instantly requires an enormous amount of energy, and if thousands of charging stations tried pulling it directly from the electrical grid at the same time, the strain would be enormous. This has become one of the biggest obstacles preventing ultra-fast charging from becoming practical on a large scale. BYD's solution is surprisingly clever. Instead of drawing massive amounts of electricity only when a vehicle plugs in, each flash charging station includes its own built-in energy storage system. Throughout the day, the station slowly collects electricity from the power grid at a steady rate that the electrical network can comfortably support. That energy is stored inside the station until it's needed. When a compatible BYD vehicle arrives, the station releases its stored energy almost instantly, allowing the car to charge at full speed without placing sudden pressure on the electrical grid. Imagine filling a large water tower throughout the day. When someone opens the tap, the water flows immediately at high pressure because the storage tank has already been filled in advance. The same principle applies here. What's even more impressive is that BYD didn't wait until the cars were released before building the charging network. Before the technology even reached customers, the company had already constructed more than 4,000 flash charging stations across China. Their goal is to expand that number to around 20,000 stations by the end of 2026. This isn't simply an ambitious presentation or a future promise. The infrastructure was already being installed while the vehicles themselves were still under development. Many electric vehicle companies struggle with what's often called the chicken and egg problem. Charging companies hesitate to build expensive stations because there aren't enough compatible vehicles, while customers hesitate to buy electric cars because charging stations are limited. BYD is solving both problems at the same time by expanding its vehicle lineup and charging network together. The company's overall scale makes this strategy even more significant. Last year alone, BYD sold more than 4 million vehicles worldwide, and that figure doesn't represent a single model. It includes everything from affordable city cars priced around $22,000 to premium luxury sedans and even six-figure high-performance hypercars. That kind of manufacturing capacity gives BYD the ability not only to introduce groundbreaking technology, but also to bring it to millions of drivers much faster than many of its competitors. What's even more impressive is that this technology isn't limited to a single premium vehicle. The same cell-to-body architecture is designed to power BYD's entire lineup. It isn't just an exclusive feature reserved for expensive flagship models. It's a platform that can be adapted across a wide range of vehicles. The same structural battery design can be used in passenger cars, pickup trucks, buses, commercial delivery vans, and even large-scale energy storage systems for buildings and electrical grids. The engineering principles remain the same whether the vehicle is a compact sedan or something several times larger. That's what makes this development so significant. BYD isn't creating a niche product aimed only at wealthy early adopters. They're building a completely new foundation for electric transportation, backed by one of the largest manufacturing operations in the world. Every major automaker currently developing electric vehicles is now paying close attention to what BYD has achieved. Engineers across the industry are likely comparing their own technology against this new benchmark and calculating how much ground they need to make up. Some manufacturers are already working on their own structural battery systems. However, no other production vehicle currently combines cell-to-body construction, 5-minute charging, strong cold weather performance, and a rapidly expanding ultra-fast charging network into one complete package. The benchmark has changed, and it has moved much further ahead. So what does all of this actually mean for everyday drivers? If you're planning to buy a new car within the next few years, this technology could significantly change the way you think about electric vehicles. For years, many people have viewed EVs as a compromise. They appreciated the environmental benefits, but worried about charging times, limited driving range, and reduced performance during winter. BYD's latest platform directly targets all three concerns at once. 5-minute charging dramatically reduces the inconvenience of stopping to recharge. A driving range of more than 600 miles removes much of the anxiety surrounding long-distance travel. And maintaining fast charging performance even in temperatures as low as -30 degrees Celsius greatly improves confidence for drivers living in colder climates. When all of those barriers begin to disappear together, switching to an electric vehicle starts feeling much less like a compromise and much more like the obvious choice. The structural improvements bring additional advantages beyond battery performance. A vehicle that's roughly 70% stiffer than previous designs offers sharper handling, greater stability, fewer vibrations, and a more refined driving experience. It can also distribute crash forces more effectively across the entire body structure, improving overall safety. Integrating the battery into the vehicle's structure provides another important benefit. In conventional electric vehicles, The battery pack sits inside a separate enclosure beneath the car. During a severe collision, damage to that enclosure can create serious risks. With cell-to-body construction, however, the battery itself becomes part of the protective structure, making the overall design stronger and more resistant to damage. There are long-term economic advantages as well. Using fewer individual components means less material is wasted on packaging that doesn't contribute to performance. More of the available space is dedicated to storing energy instead of supporting unnecessary structural parts. A simpler design also makes manufacturing more efficient. As production improves over time, manufacturing costs can decrease, making the technology more affordable for a much larger number of buyers. Today, these innovations appear in premium flagship models, but history shows that major automotive technologies almost always follow the same path. They begin in high-end vehicles, where development costs are easier to recover and gradually become available in more affordable models as production scales up. Electric vehicles have always been expected to reach a point where choosing one over a gasoline-powered car no longer feels like making sacrifices. Limited range, long charging stops, and poor winter performance were never meant to be permanent obstacles. They were engineering challenges waiting to be solved. BYD's 2025 announcement suggests that, at least for them, many of those challenges have now been overcome. That also means the rest of the automotive industry has a lot of work ahead if it wants to keep pace. When you step back and look at the complete story, it's remarkable. A company that began in a small rented room manufacturing batteries for mobile phones has gone on to rethink the very foundation of electric vehicles. They didn't simply build a larger battery. They redesigned the entire car so the battery became part of the vehicle itself. If you found this video interesting, don't forget to hit the like button before you leave. It only takes a second, but it really helps the channel continue creating content like this. And be sure to subscribe and turn on notifications so you never miss future videos. We love exploring breakthroughs like these before they become the biggest headlines in the industry. Now, I'd love to hear your opinion. If a 5-minute ultra-fast charger were available near your home today, would that be enough to convince you to switch to an electric vehicle? Leave your thoughts in the comments below. I read every single one, and I'm always interested in hearing what you think. Thanks for watching, and I'll see you in the next video.